My name is Petra Graatsma and I work as a program support manager at CIRCO. And I will be your host today in this session. I want to start introducing CIRCO and the new initiative, the platform Circular Design, with you. I start sharing my screen. I assume that most of you know CIRCO, so I will not tell too much about it. The only thing I would like to share with you is that we are expanding our network. We have currently 5 regional hubs in the Netherlands and 5 in formation, so almost a hub coming up in the Netherlands. And we have 11 hubs abroad on different continents. For example, in Portugal, in Germany, in Sri Lanka, Brazil, Turkey. So in a lot of different places, we have CIRCO hubs. These hubs have the ambition to train more than 750 companies in the Netherlands and abroad with our CIRCO tracks. As the network, as I mentioned, the network is expanding and there's more and more interest in circular design. We saw a need to do more about sharing and distributing the knowledge that there is about circular design. And that's why we started the initiative of a platform, Circular Design, in spring last year. What is this platform? We have started working on it, on defining the scope and the objectives and the activities of this platform. And we received input from more than 25 different parties and co-created on how this platform should look like and what it should do. This resulted in a shared ambition to develop this platform, and it will be called CIRConnect. It's not yet live, but soon you will hear more about this. And at this moment, 10 parties have started to cooperate on this platform. You'll see here the different logos of the different organizations. And of course, it's open for more parties. What's the ambition of this platform? As I mentioned, it's a network of collaborating parties who do everything to collect, to contribute, to enrich, and to distribute their knowledge of circular design. So that companies and designers can apply this knowledge and that other parties are fed with the insights, which they can translate into improved system conditions, because this will accelerate the transition to the circular economy. About today's session, this is exactly an activity that we want to organize from this platform, and where like 3 different elements come together: the knowledge, the network, and we call it applying. It's meaning that you can put it into practice, or it prompts to action the knowledge that is shared. This brings me to the subject of today. We have chosen a very specific and relevant design topic, the ease of disassembly. We see recently more and more interest and attention for this subject. It's because of upcoming regulation, customer requests, for example, the repair cafes, and circular ambitions of companies. What's the program of today? We will start the session with Bas Flipsen from TU Delft. He's an expert in this field and will show 2 different tools to assess this ease of disassembly. Maybe you even recognize him later on when you see him, because he was on the Dutch television last week in Nieuwsuur about repairability. Thereafter, we will have Francisco de Vasio. He studied at TU Delft, and I believe he even graduated with a 10. And he did his master thesis at Philips. And he is now working for Philips Engineering Solutions as a circular product design expert. He will elaborate on the way of working and the challenges that they come across within Philips. Last but not least, we will have Tom Evers, CIRCO trainer and owner of a design agency, and he will tell you more about his own experiences and show some solutions that can be applied into daily practice. If you have during this session any questions, because we are with a big group of people, please ask the questions in the chat. My colleague Peter van Os, who is CIRCO's Program Manager International and also the expert team lead, he will monitor the questions in the chat and will make sure that these questions are being answered. After the presentations, we will go in small breakout sessions, and there we have time to discuss and exchange ideas about 2 questions that we have for you. And we will end the session with a plenary conclusion. Now, the session will be in English. It's not my native tongue, you can hear that. It's also not the native tongue of the other speakers, but we do our best. If something is unclear or you don't understand, also please use the chat. Now, I think everybody's microphone is already muted, so that's good. I will stop sharing my screen. And before I give the floor to Bas, I want to do a short poll to get to know you, so that we have a little bit of an idea like who is in this audience. I will start it now. And there are 2 questions in the poll. So you see first one question and you go down and you see the other question. This first question, in which area do you work, or are you a student? And the other question is, how much experience do you have with circular design? It's going fast. Yeah, almost there. End the poll. Share the results. Okay, so we have 47% business, 22% design agencies, are these designers, 8% education, 8% research, 2% government, 2% non-profit, and 10% student. So it's a good mixture of different people. And just to have a look at your experience, oh, there are 30% beginners. That's interesting. That it is an expert meeting, so I hope you can follow for all the beginners, but of course, 33% intermediate, 27% advanced, and only 10% are daring to call themselves an expert. Now, it's also a good mixture, I think. I'll stop the poll, and I give the floor to Bas to present, so you can share your screen, Bas.
No, desktop, yes, there we go. I think you see, yeah, all right?
Yes.
All right, welcome this afternoon. My name is Bas Flipsen, I'm from the TU Delft, and I was asked by CIRCO to do a small presentation on Hotspot Mapping and Disassembly Mapping. I'm going to tell you about this in this presentation. With these tools, you can pinpoint circular hotspots in your product architecture, and the method can be used to redesign the architecture of your product, making it circular ready for all recovery strategies as defined by the circular economy scheme. And now, let's see if this works. Yes, already back in the 90s, a number of methods were developed to assess the ease of disassembly of products. In those days, these methods were already considered as important for environmental reasons, in particular for product recycling. And on the left side, you see disassembly tables, which were used to quantify the ease of disassembly. And on the right side, you see the reversed fishbone diagrams, which visualizes the disassembly process. So this is already started out in the 90s during the eco-design period. But recently, this work has come under renewed scrutiny because of the Green Deal and the commitment of the EU Commission promoting circular economy. And recent material efficiency standards like the EN 4555X series focuses on general methods to assess products on all technical loops of the circular economy. The latest pupil to this standard is the EN 45554 standard, which promotes a general method for assessing of the ability to repair, reuse and upgrade energy-related products. And it finalizes the series of standards, and it's a good thing, I think. In this standard, the identification and ranking of so-called priority parts is the first step in assessing a product on its repair, reuse and upgrade. In the standard, a priority pass is determined by the likelihood for replacement or upgraded. Second, the suitability of the part for reuse and the functionality of the part. The standard touches on the most inner loops of the circular economy scheme. On the other hand, we have the EN 45555 standard, which promotes recovering materials for recycling purposes and focus on recyclability and recoverability rate and the efficiency of recycling and recovery processes. And thus touches upon the most outer loop of the circular economy scheme. However, both the EN 45554 and the 45555 do not consider the environmental benefits of avoiding the production of equivalent amounts of primary materials and energy carriers, nor the impacts associated with the end-of-life treatment processes. Before designing for ease of disassembly, you need to know how to assess a product on its ease of disassembly. And this is the reason why we developed the Hotspot Mapping method, which allows a designer to focus on the recovery of priority parts, as well as those parts with a high economic and environmental value, the valuable parts. And together we like to name that the critical parts. So it's a combination of the EN 45554 standard, which focuses mainly on priority parts, parts that can fail and will fail during life and prolong life by repair. But we also focus on the environmental benefit. So exactly the golden valuable parts. Yes. All right, together with a visualization of the teardown sequence, just like you see in the so-called disassembly map. And this is one of those maps. It is possible to locate the critical parts in the product architecture and assess them on the ease of part disassembly. And hotspot mapping is a method to pinpoint these critical parts, locate them in the product architecture, and to assess them on the ease of disassembly. So the hotspot mapping method is a spreadsheet-based tool that indicates ease of disassembly by flagging 5 hotspot indicators. First one is time needed to disconnect parts. So you actually log the complete process and you log the time needed to disconnect a part from the rest of the assembly. The second is the difficulty of access. For instance, the amount of force which is needed in prying into your product, and is it actually feasible to reach to the connector. The third one is the parts failure rate and maintenance needs, defined by the repair standard as the priority parts. The fourth is the part of the economic value, and that's where you need to have the weight of the different parts. So you need to, by disassembling, you actually have to measure how much it weighs. And with that, you can calculate the part's embodied economic value and also the embodied environmental impact. Where the first two are activity-based hotspots, so how difficult it is, what type of tools do you need, etc. And the last 3 are parts-based hotspots. The assessment, I hope this video starts now, you can see it. The assessment of the product focuses on product-related aspects. And over here you see my blender, which I disassembled completely, and I recorded it on a video, and not on context-related aspects, such as the availability of spare parts or health and safety risks. We don't focus on that. That's for other concerns like the new EU regulations on repairability and the new repairability scoring, which will come up in this or next years. Or the French repairability index is also part. But it also focuses on, for instance, the availability of spare parts and manuals, availability of service manuals or maintenance manuals. We only focus on the ease of disassembly. So the method consists of 3 steps. recording of the teardown operation in a spreadsheet. So actually fill in every step you take by disconnecting. So you actually disconnect every part from the assembly and you fill out the spreadsheet with a large amount of information, followed by the hotspot identification based on the previous defined indicators. And the third steps consist of locating the hotspots in the product architecture by making a disassembly sketch or a disassembly map and figure out how deep critical parts are nested in the product and what hurdles have to be overcome to reach them. Last step is not discussed in this presentation. While disassembling the product, the operator logs the necessary data consisting of 5 properties: the general properties, describing all activities, tools, and actual time involved; the difficulty of access, consisting of the force involved and difficulty of positioning the tool; the fourth group's activity properties, sorry, I forgot one, which consists of descriptions of the activities, and of course the general properties, that's the one I forgot, the parts or assembly name. So that's really important. So actually you have to name the different parts. The fourth group consists of functional sensitivity properties and concerns the failure rate, the amount of maintenance, and the prioritization of the functionality. This is quite difficult to get, but actually this is the research you need to do if you want to do this assessment. And the last group consists of material properties consisting of the type of materials used in the part and its weight. And you have to determine what type of material it's made of. And we have made it very simple. So we talk about metals or aluminium or that kind of stuff, and plastics and that kind of stuff. So we're not focusing on, for instance, ABS or very specific plastics. To illustrate the tools and its functionality, let's run through a case study. This is the blender. Figure out the circularity of the Solus 837 blender. The product consists of 2 major parts: the bottom base motor assembly, which you see on the left, and the top half can assembly, which you see on the right. The teardown is limited to non-destructive operations alone. This means no desoldering or no cutting was involved in disconnecting any part from the disassembly or from the assembly. The product consists of 39 parts, for which 55 disassembly operations were needed, and 6 different tools were needed in 12 operations. So that's quite a lot. High repairable products often have a low amount of tools, or maybe no amount of tools, so only your bare hands. In all operations, other operations were executed using the hands, and the time required for disassembling was critical for more than one part. So let's see what we have over here. Especially step 11 and 13 took a while to disconnect, and this is the bearing module, which you see over here. All operations were relatively easy, but only to take out this bearing module, which is connecting the bottom motor assembly with the top can assembly, took a while, and it was really difficult to reach. And this actually failed. The rubber sleeve, which you see surrounding the bearing module, actually deteriorated because of high acids of the oranges I use in my blender, and it dripped through to the motor, and it actually the rubber actually deteriorated a lot. Here you see an overview of all steps involved in disassembling the Solus blender, and this is where you can see also step number 11 and step number 13, and 2 flags will pop up, which shows that on a time consumption based part, this is really a step which can be improved. Both parts are crucial for functionality and therefore are very important. 3 other parts are red flagged due to the environmental and economic indicators. Oh, here you see it more precise. I just added this one. Why this is such an important part and how difficult it is to reach this one. The 3 other parts which are really important is the glass jug, the metal blender case, and the can bottom. And of course you can imagine all types of steels you're using, and stainless steel in this case, And glass, which is being used for the can, it actually absorbs a lot of environmental embodied energy, and it has a high value. So these parts are really important for recycling, but also maybe for repurpose or reuse. Yeah, this means these parts are worth harvesting in a recycling scheme and thus should be easy accessible. Well, the jug was really easy to take off, and you could take apart the parts very easily. In this case, both these parts are easy to reach. This is not the case for the DC motor, which is the fourth hotspot part in this disassembly, and it's really important, as can be seen from the hotspot table. The motor has multiple red flags. This was the main important part. It could fail often, and actually contains a lot of materials which have a high value and high environmental embodied energy, environmental impact. Sorry. Because it contains copper and the neodymium magnets, it shows up as a priority part in both economic and environmental value indicators. Besides these value indicators, it also scores high on the time and priority part indicator because of its primary function. And both the value and the priority part indicators show the importance of this part, while the time indicator shows the difficulty of accessing this part. It thus shows the hurdle for any reuse or recycling scheme, and there's room for improvement to be found here. So actually accessing the motor is something which we should strive for as designers.
Bas,
yes.
You have 5 more minutes.
All right, next step is to visualize the disassembly in tree form, like this sticky notes. I call it disassembly sketching. You start out with sticky notes, and you make parallel and series disconnections, and like the tree you saw before, the disassembly tree. This tree will give you insight in the steps needed to reach a critical component, and especially defined by the hotspot mapping. You can also make use, as a first sketch, make use of this sticky notes, which I think is really easy because you can make changes very quickly. After finishing this, you can, of course, after which you can perfection it and make a visually be more appealing and more information rich disassembly map, like you see over here from a vacuum cleaner. Francesco remembers this one. In this map, you can pinpoint these critical parts and the depth it is seated in the product architecture. Together with Francesco, we have developed 3 design strategies to improve the ease of disassembly. And that's something which I can tell you now, after which you can improve the ease of disassembly. This is best explained by a stack of pancakes, where every pancake is a part and the number of pancakes refers to the number of pancakes refer to how much you have to eat before reaching this very juicy pancake. The first redesign strategy is surfacing, which is a technique where we try to decrease the number of steps needed to reach the critical part, and in other words, raise the part in the disassembly tree from bottom to top. Ask yourself if there are critical parts which can easily be placed more to the top. So accessing the motor by adding, for instance, an easy accessible part which you can take off and take out the motor. You can make use of the disassembly tree to see what the consequences are. The second redesign strategy is clumping, where parts are grouped together and form a sub-assembly. Redesign your product in such a way that the sub-assembly is taken out in one go, and freeing up the critical parts which can be liberated in a sequential step. The critical part can be part of the main assembly, but also part of the sub-assembly. And if you want to read more about it, you can read Francesco's report on the repository. All right, the third technique is trimming, which focuses on bringing down the number of and the time needed for critical activities. So actually unscrewing 25 screws and bring it back to 1 screw is one thing to trim down the amount of time needed to disconnect parts. Rethink the current use of fasteners. That's the goal. And summarizing, hotspot mapping is a method to systematically evaluate a product architecture and identify hotspots and ease of disassembly. It combines a gentle dismantle of a product with the logging of all disassembly operations and part properties involved. Besides priority part identification, it also assesses the product architecture on economic and environmental value of the parts. I think that's really important, which is not part of the standards or the new European Committee regulations. In this way, it gives designers an improved focus for redesign towards a circular economy instead of only on one loop. Using hotspot and disassembly gives the designer insights in the way the product is built, and by using the 3 presented redesign strategies, in a very nutshell, by the way, you can improve the product architecture by making critical parts more accessible. Besides developing these tools as scientific output, we try to apply all the learnings and educate people who are interested. The hotspot and disassembly mapping is part of the bachelor course Circular Product Design, and we improve the tools and methods with graduate students working on design for R in the field of, for instance, vacuum cleaners, baby car seats, caravans, and bicycles. And this is often done in cooperation with companies, like in this example, where one of the students, Bente Vermaat, redesigned this baby seat towards a more, it's a safety critical product to make more refurbishable product, which is really rather difficult. We improve the tools with graduate students. Besides students, we try to reach out to the design community and have developed on-campus masterclasses and online MOOCs, like you see over here. You can find more on that on onlinelearning.tu Delft.nl. And in general, we think we've developed a simple and applicable approach for assessing consumer products on its ease of disassembly and its circular readiness. And this approach is found to be useful for designers to analyze current products on the market and improve their product architecture, making them fit in any of the recovery strategies within the circular economy. Thank you very much. Was it within the time limit, Petra?
No, it wasn't, Bas, but it was very interesting. So thanks for that. And only 2 minutes over time. So you say it's a simple tool, although you have to do a lot of steps. Is it right that the MOOC is supporting designers to use this tool, or that you also have trainings to use this tool if you want to start with it? You're on mute, Bas.
MOOC on circular economy does not contain this one. We have a professional education course online, which starts out in May, where we actually run through this process over a time period of 5 weeks. And participants, mostly people from the design community, actually work on that for 4 to 8 hours per week. So it's about that's what the course is about. It takes a while to disassemble a product, to make a gentle dismantle, of course, and to fill in the forms. Besides hotspot mapping and disassembly mapping, we also introduced the Circularity Calculator, which gives you a monetary an insight in how much money can be made with certain strategies, like refurbishment or remanufacturing.
Okay, and so this example was for a electronica product. You also mentioned some other products. Are there some characteristics of products that suit better with your tools than others? So what type of products would you exclude, and what would you include for this method?
Yeah, let's talk mainly about complex products. So simple products, we've done this as well with, for instance, bicycle tail lights. So the throwaway tail lights from the HEMA, for instance, but they consist of 9 to 10 parts max. And it's a good one to learn the tools, but actually it doesn't give you a very good insight in how to improve it, because there's not much to improve on those products. Especially complex products with lots of parts are generally useful for this kind of approaches.
Okay, thank you. One last question from the audience, and that is on also the availability of spare parts. And so spare parts are not always available, and so you can also use 3D printing for that. Is that also included in your approach, making that available with 3D printing programs?
No, but that's not in this hotspot and disassembly mapping tool. Is really an assessment tool. Designers can of course well, redesign products based on this. We have another project which is the share repair project, where we actually focus on design 3D printing for repair parts. So actually design parts for using 3D printing. But to be honest, if you replace an ABS part with the 3D printed ABS part, the performance will be a lot lower. So
okay.
keep that in mind.
Maybe we should take this as a topic for the next expert cafe. So
it's
thank you very much.
Thank
you very much, Bas. And so maybe you can stop sharing your screen, and then we can ask Francesco to give his view on what's happening within Philips. Francesco, the floor is yours.
Yes. Let me see if I can share my screen.
And so again, people, sorry, if you have any questions, put them in the chat.
Yeah, can you see my screen?
Yes.
Great. All right. Well, hi, everyone. My name is Francesco De Fazio. I'm a circular product design consultant. I work at Philips Engineering Solutions. So maybe as a bit of context, Philips Engineering Solution is an organization within Philips. We provide engineering support mainly to Philips businesses, but actually we also work with external companies. So we also do projects and we support companies that are not Philips. Many times people don't know that about us. I'm part of this team that is mainly focusing on sustainability implementation. We look into a lot of different topics around sustainability. I specifically look into circular design. And apart from us, we have also other departments working, for instance, on topics like mechatronics, reliability, supply chain, manufacturing, and other things. So I wanted to start today from the main challenges that I personally see. So again, this is my experience. I bet that if there are people in the code that worked on disassembly in the past, they will recognize a lot of the things I'm going to say. But here you can see a bit the key challenges that I always see popping up in any projects I've been working on where we looked into disassembly. Overall, I think there are two distinctions to make. Of course, based on the type of product you work on, challenges might look a bit different. In my experience working mostly between Philips, we have consumer products and we have medical equipment. And challenges really change a lot depending on which type of category you work on. The key challenges for consumer products is first of all, impact of disassembly on reliability. This is always a key challenge that immediately pops up when we do a project on disassembly. Reversible connections, disassembly overall can have a negative impact on reliability. You can imagine that using, for instance, connectors on a PCBA over soldering might be less reliable, many times is less reliable. The most reliable thing, of course, is to glue everything together and just solder everything together. You can imagine that also on water-type products, disassembly can have quite an impact on durability. So we really have to know how to properly design for disassembly considering these topics. Just to give you an example, if we have, for instance, just 1% in increasing core rates for a product that, for instance, we must produce, so let's think about 4 million units, that is 40,000 products that the manufacturer see coming back from the market and that must be replaced. Another problem is, of course, cost. So, of course, disassembly many times adds on top of the BOM of a product on the production cost. Reversible connectors are also often more expensive than non-reversible one. Again, connectors over soldering a component. I often hear a lot of people many times saying, you know, how much can it cost a connector? Well, it can cost quite some money, right? If we consider mass-produced products. Again, as an example, let's think about 10 cents invested in 1 or 2 connectors on a PCBA. If we multiply that for 4 million units produced, that can become close to $500,000 investment for a company. Other challenges are service cost. So if we consider the labor cost, the spare part cost, the logistics to take back the product and repair it, that often adds up to a cost that is close or even higher than just replacing the product with a new one. This on the manufacturer side. So we see a lot of manufacturers doing it and have been doing it in the past, just sending a new product as a replacement. And we also see it after the warranty period, where consumers can decide if they want to repair or not their products. Most of the time, at least on the consumer products that I've been working on, we see data that consumers are not willing to pay for that because the cost is so high that many times it's just more interesting to buy a new product. Other issues that we see is that if we improve disassembly, we can be sure that consumers will try to repair the product. And this is seen as a unnecessary liability by companies. Overall, all these topics, they represent risk and cost for companies. And if there are no clear and strong value drivers, very often becomes challenging to really push this topic forward. And the problem with disassembly is a bit that in many cases, there are still not yet strong enough and clear enough value drivers to implement this topic. Of course, there are new repair regulation on the horizon in Europe, but also in North America, we see things coming up. Many times the timeline is a bit unclear. We can expect that at the beginning, some product category are going to be tackled. And at least what I see from my experience is that this is not yet a sufficient driver to actually push this topic forward on its own. On medical equipment, we see some specific challenges. For instance, on big medical equipment, we have part harvesting operation already in place. Many times there we see that we have some limitations on those components that perhaps are developed and by external suppliers. So you can imagine that when we develop a big system, there are some parts that are not fully developed and produced by Philips itself, but there are external suppliers that provide them. In that case, there are some legal limitations on what can be remanufactured, what can be reused as a spare parts, because for instance, in Philips is not the DMR owner, so we have to send back the part to the original OEM to do that process. Other important challenges are how to quantify real labor cost benefits. This is also something that I hear very often, that the biggest business case for disassembly is decreasing the labor cost involved in repairing the product, right? So you made the product faster to repair, that means that the technicians has to spend less time on that, and that determines a cost saving because you pay less the technician to work on that. Well, I see, at least from my experiences, that often not really true. So there are fixed tariff, fixed pay rates, there are overhead costs, and that means that making a product faster to disassemble is not directly proportional to the amount of money that you spend. And finally, what we also see as a big challenge is that it's difficult to assess the remaining useful life of components. In some cases, we would like to harvest and reuse some components, but you can imagine that the company must be 100% sure that that part can withstand a second life. And many times that's a very difficult thing to do. For instance, we would need to integrate monitors and sensors that can monitor the physics that apply on the part over its life to then do some estimates and statistics on if the part can be reused or not. So does all this means that we should stop pushing for disassembly? No, it does not, but it means that we really have to use a very structured approach and comprehensive approach to push this topic forward. In my experience with this, is not enough simply to assess a product and to suggest, for instance, to use a connector rather than soldering. Because of all these issues that we see, this risk and additional cost the company sees in doing that. So I wanted to briefly show at high level the process that we have been using in the past. It's definitely not the perfect approach, right? Is something that we continuously try to improve over time based on the projects that we do and how it works and the experience that we create. So maybe a few things before diving into that. I think there are some concepts that are very important to keep in mind before we talk about disassembly. Circularity occurs on two main levels, and they are reinforcing one another. One is the circular proposition and business model, and the other one is circular design readiness. If we don't have a circular business model, there are no value driver often to design for circularity. There is no real business case many times to do that. Companies are not willing to take that extra cost and risk into account. At the same time, if we don't have a circular design readiness, our circular business models will be inefficient and profitability is low. We saw it in the past where we went full in to create a new business model that is full or partially circular. The product was not ready for that, and then we see huge inefficiencies there. Another very important thing to consider since the beginning is that disassembly is not our end goal. We are not doing disassembly for the sake of disassembly. We are doing disassembly because we want to achieve circularity. Disassembly is a design enabler that can enable different circular strategies. Strategies like repair, upgrades, refurbishment, parts recovery. Our end goal is those strategies, and that's what we should define before we start to do any assessment of study on disassembly. Also because the way that you design for disassembly for repair, for instance, can vary a lot, can be very different compared to the way that you disassemble for, you design for disassembly for refurbishment. So the strategy must be defined first before going into how the design should be optimized.
Francesco?
Yeah.
You have 4 more minutes.
Oh, wow. All right. I'm going to try to speed up. So to do that, we defined this high level, 3 levels approach. The idea is that what we always try to do as a first thing is to understand what is the most suitable, sustainable strategy for the product and the context that we are working at, that we are looking at. Sustainable strategies that could be more eco-efficiency related strategies. So for instance, energy efficiency, or more circular related strategies like repair. After that, so after identifying the correct sustainable strategy for our specific product, we go to the level of design strategy. So what do we have to do at the design level to enable that overall sustainable strategy? And here we find disassembly next to a lot of other strategies that I feel many times perhaps we neglect. And at this phase, then we do all the assessment work. We use a lot of tools developed also with TU Delft, also what Bas showed earlier, to identify what we call design focus areas, those specific things at the design level that should be improved. How do we identify the most suitable sustainable strategy for a product? We use some methodologies. One of them is product lifecycle mapping. So it's very important that we are fully aware about what is currently happening through the product lifecycle to the product to understand what are the opportunities. How can we make this lifecycle more circular? Then we, of course, use lifecycle assessment to understand exactly what are the hotspots in the environmental impact of the product. We want to avoid that we put a lot of energy and resources in solving something that perhaps does not have a lot of impact. We identify boundaries conditions as well. There are a lot of, for instance, legal, quality, and safety constraints that have to be taken into account when we define a strategy. We might start to designing for repair and then finding out later on that we are not legally allowed to repair a product. And finally, but not least, because it's one of the most important, is business modeling. So the most suitable sustainable strategy for a product is also the one that is economically sustainable. It's unthinkable, in my opinion, that a company is gonna start to go towards a sustainable strategy if it's not profitable, if value cannot be created. And then based on that, we identify what we must do at design level. So this is a very high level framework that we use in Philips. I really like it because it really shows you clearly how circular revenue, so the business model part, connects with the design part. So here you see the circular readiness, the design features necessary to enable the different main circular revenue strategies. So you can see, for instance, if we want to design for refurbishment, these are the things that we should take into account. And you see this assembly popping up here, but is next to other 6 design features that must be considered at the same time. And maybe another things that we learned, and I think we learned in the hard way, is that we really have to bring this up as early as possible in the design process. Here you can see 4 high-level phases of the overall design process that are used in Philips, but in a lot of other companies. Here I'm really talking about the overall development process, so not just the moment where we start doing some sketching, but really the moment where we define what are we trying to do here, what is the proposition, the business proposition that we are trying to create. And in this phase is really the phase where we can really rethink how can we create value for the user and the company in a more sustainable way. How can we change our business model, and what are the necessary design enablers? So here we really define since the beginning, this is what we want to achieve, and that's why we need this assembly. This is a de-risk strategy. That means that if we present the topic later on in the process, it's going to be very difficult to integrate because risks are not accepted anymore. We cannot change what has been defined here. So I wanted to give an example of when this assembly works. I think good example are all Philips big imaging systems. These are serviced, upgrade, refurbished, parts are recovered from them. Why this worked? Because there are clear value driver for the topic. So we have a high value of the equipment. Hospital, that is our customer in this case, is expecting services and is willing to pay for it. So there is a strong business case. There is a market for refurbishing, and harvesting parts can help to avoid last time buy or to avoid the scarcity of phased out components. You can imagine that if a product starts to have to last for over 15 years, you really start having issues also with spare parts availability, and this can really help. And there we start seeing crazy innovation happening. So for instance, remote monitoring, remote diagnostic, predictive maintenance, and preventive maintenance. So being able to predict when a part fails before the part fails, and so that we can replace it before it even fails. So if you want to know more about our specific process and tools and methods to design specifically for this assembly, we made a webinar about it called Making Circular Innovation Work. We are going to share the link after this session. And there we present in more detail the tools that we use in this process, some of which have been developed together with TU Delft. Yeah, so that's all. Feel free to contact us if you have any questions. And as said, we also work with external companies as well. So if you need any support, feel free to reach out. We work on disassembly, but also beyond that. So we have also experts on recycling, sustainable materials, lifecycle assessment, and a lot of other things. Yeah.
Well, thank you very much, Francesco. This was a very detailed look into your kitchen and so all your experience. There were no questions from the audience, but I have one question. So I can imagine that the way you design and also your value drivers are different when you allow a user to repair, or you do repair on site, or you design for industrial refurbishment. Is that right? And maybe the last one is more relevant and more easy to realize.
Yeah, definitely. So I think overall, some drivers could be more interesting. Some solutions could be more interesting than others for specific product categories, right? So if we think about the big imaging systems, it's very difficult to think about consumer repairs, for instance. So probably the value drivers, we have to look somewhere else. If we look at consumer products, we know the regulations are coming up. Consumers are becoming more sensitive to the topic. So consumer repairs could definitely be a very strong value driver to consider. And there are a lot of benefits there as well, also the business level that can be explored.
Okay, well, thank you. So the last speaker for today is Tom Evers, and he's going to give some very practical examples of what he is doing in his day-to-day business as a design agency. So Tom.
Yes, thank you. Yes, my name is Tom Evers. I'm owner of Demonteren and Evers Design and also a CIRCO trainer. Next to this stories where you see that design for disassembly can be very difficult, I would like to show you that it can also be easy, because sometimes you just have to start on it. So I will share my screen, and I think now you can see my screen, huh? Is that okay?
Yep.
So first of all, and also Francesco told it, it's important that you know where you want to use this disassembly for. You see the value hill for the newcomers of circularity. This is a hill where you can see where you start from having your developing your products from raw materials to industrialized to components to retail to at the end it's by the consumer. Then it has its highest value, and if you go down, you throw the product away, it goes down to zero. And if we repair products, the value stays the longest. We can reuse it, it stays longer, and then it's refurbished, then it's remanufactured, and recycling is almost the end of it. So it's more interesting to look to repair or reuse or refurbish than to the other one when you look to business-wise of the value of a product. And that's of course what we also try to explain to companies when we do the CIRCO class. That's interesting how you can create business models around these upper topics, not only in the recycle mode. But if we want to do a disassembly, it's necessary that we know where we do it for. Is it during life disassembly? Do we want to repair or refurbish one? Or is it the end of life disassembly? I put it in this too, but in fact it's a kind of between, right, like remanufacturing. But if you see also in the trends what are up, then you see that the majority of the people, they would like to repair products instead of buying new ones and throwing them away. So that's quite a high number. If you read this, then it's quite astonishing that so many consumers want to do it. And you see also that there are coming new things up that you see in France. They implement the repairability scores. You see that they're coming up more services for upgrades. You can also have more upgradable components. You see that the topic where we talk about today for designers disassembly is something which comes in more also in the developing process for product design. We see that spare parts are getting more in circulation, and we see that they're coming tools of trades, also networks which are more connected and giving more information and give also access to information that you can see how you can disassemble a product and by YouTube or whatever platforms there are. That's what you see by consumers. But the other thing is that if we have consumers, then we see also consumers are quite lazy, and yeah, they are not always willing to go very deep in disassemble a full product. So it has also to have something that's very easy to access and easy to do by consumers if you want to let it done by consumers. And that's also what you see, that it's not only done by consumers, but you see also other companies who step up, who do the repair for you, like the bicycle repair or your car is repaired. You see also that other companies come to refurbish your products, and later on you see also that other companies, they make a kind of closed loop disassembly. They create their own products, so you lease your product and they get it back, and they will look for the disassembly for themselves. And it's interesting to see how you can do it. This is an example what we did for Sky to make a remote, and here we made a remote where it has only one connecting point, and which you can easily dismantle by pushing that point away, and then you have a quite simple disassembly product. And of course, then you design something of that, but it needs also a kind of machine where you can do it effectively. So the impact is not only on the product, but it's also on how you're going to use it and how you're going to do it industrialized in your process. And it's of course, if you do a project like this, that's something completely different than when you do a consumer disassembly. I made just a proposal, just a quick sketch. We did it with one of my designers did it to just show you that it's not difficult to do something to make a design for disassembly, but it's just a different way of thinking. And I would show you like this with the office chair. If we look to an office chair, then we see that there are a lot of components which need to have a repair, which it will break earlier. So we have the backrest, we have the armrest, we have the seat, we have the gas strut, and we have the casters. Those are the main parts which will have the first type of repair. And if we look then to pick out one, let's say the backrest, and then we can think about, okay, how does we want to have this repair? Is this a repair that we want to do it by the consumer itself, or is it a repair that is going to send back to the original distributor or producent, and he's doing kind of refurbish on it. So that's something you have to take in account, also how to organize it for it. But just to give you an example, if we took a product here, we took it apart, and then you see already how difficult it is to do this. At this moment, there are a lot of invisible connectors. There are all different kind of connectors. If you want to get it loose, mostly you demolish it and you really destroy it. So it's quite complicated to do it, and in fact the whole design of the chair is not made for disassembly, so then it's very difficult. But if you look at it and how to solve it, and you say, okay, we want to solve it to make it easy, accessible for disassembly, then you could easily make something which you have only one point to disconnect it, and then you can shift out your backrest. So if it's an option what you could do in a very simple way, which costs not more money to do if you develop it in the right way, and it's easier to access. And then if you do it like that, then it's also interesting for companies like Ant or the other companies to refurbish their parts and to make it accessible also for consumers to send it easily to their company, and that they can refurbish it and send it back, etc. And they have a better control about the whole system. Yeah, this was in a very short session because I had only 10 minutes, and I think I managed to get it in 10 minutes.
So thank you, Tom. And so good that you have also this perspective that for a product as a chair, you can maybe have some very, well, not very easy, but at least some things that you can do easily in order to improve the disassembly rate of it.
What I wanted to mention is that you can make it very complex, but sometimes it's also simple. So we have just to start with it and do it, and yeah, then you will come quite far. Most products are not made to disassemble. Yeah, and that's the key.
Yes, and you also gave a value driver for instance, Arend, how they can also make business out of it, so that there is also a yes. Business motivation to do so. Yeah. Well, many thanks for your elaboration. Peter, you are going to introduce the breakouts. And you're on mute.
Yeah. We would like to go in breakouts because we can imagine it's a lot of information to digest, and it's also nice to talk a little bit about your own experiences. So we have prepared 2 questions to discuss in the breakout session. So what's according to you the biggest hurdle to make products easier to disassemble, and of course it should also be possible to reassemble, and what could you do differently in redesigning a product? What would be a step what you think would be, like Tom said, easy to take. I also share the questions in the chat, and I will open the breakout rooms right now, where you can discuss among each other about your own experiences. I open the rooms.
The people in my break
This
room,
meeting is being recorded.
if they had specific questions, and indeed I think we talked about that, and also about aesthetics, right? They play also an important role, and we have to know how to take that into account when we design for disassembly, because disassembly can impact aesthetics as well.
Yeah, well, that was exactly what came up in my group. So the aesthetics are very important, although you can wonder why is it important, because nobody's opening a product. So that is, so design is also an art, and it's also the proud of the designer. So maybe it has something to do with that. Marine, you were also in another group doing some moderation. Did you come to very serious outcomes there on how to use design for disassembly in the future?
Yeah, maybe. We discussed the difference between consumer products and professional products, since we have, well, we had a mixed group. And in the end, we discussed my own tablet here. I'm not showing the brands, but I think you can imagine what it is. This one is really functional, but it's not really easy to dismantle because there's no screws. So this can only be damaged or roughly dismantled in a rude way. And we were discussing how we can convince consumers to bring this one back to a facility where they could refurbish it in a way that, you know, maybe they harvest components or even the materials, or maybe they can update the memory, because that's the reason why this product is not useful anymore for me. Well, there we came to the conclusion that we need a business case for consumers as well to, you know, convince them to get the products back. But in the end, that is not the discussion that we were asked to do, because we were discussing, you know, how to dismantle this one. This one is really hard.
Yes.
Yeah.
Okay. Well, thanks. And so, well, that's also a relevant question. Who of you ever disassembled his own or her own product? So that's also interesting. And what do you then learn? Bas, you, of course, you were giving us a lot of information. Did you have some relevant feedback in your group, or?
Yeah, first of all, Marine, you have to use a heater. So you can, with a phone, a hair dryer, you can actually heat up the glue, and then it will soften a little bit. And then you need the pliers to disconnect the screen. And most smartphones work like that. So, and tablets work like that. So keep that in mind. No, we had a discussion. Marit had a project from wehardware.com, I think, Marit. And well, we had a discussion about durability and sustainability. So durability, how long can it work without breaking, and versus modularity, so easy accessible, easy repairable, or easy swappable of parts. And I think it's a constant dilemma. And we had a chat about that mainly, I think. Maybe you can add something to that, Marit. I don't know if you want. But I think that was the main discussion. So yeah, well, what to go for? And I think as designers, you have to make a choice. Just like Francesca also said, we have to make a choice from a business case, and then we can actually design for refurbishment and use certain tools for that, I think. But we can make it easy for people as well. Marit?
Okay.
Oh yes, we jumped from circular electronics to what was it? A big water installation to a coffee. That's the size we talked about.
Okay. Well, thank you very much. So I think it's time to wrap up. I think it was a lot of information. So thanks to all the speakers, but Petra will thank you later. And I think so. The conclusion is that it is very relevant to disassemble your own product. And Michiel even had another approach, and that was the drop test. So you can also drop it and look what's happening with your product. That can also give design improvements. And so many of you already did. And well, so that is what you can do yourself with the tool that Bas explained, can give you a lot of more insights and do it in a very structured way. So that can be very much helping you. And so there are techniques available when you have done this analysis, how you can improve. So with surfacing, clumping, trimming. So that's interesting. And so that's, I think, a good start and can help designers also to, well, to act upon what they get out of their analysis. And on the other hand, this whole disassembly is also a new field, and there is coming pressure from government and from regulation, but it's new. So I think it's there's more to explore, and you will also then see that there are many trade-offs. So with cost, but also maybe with all other circular objectives that you can have, like durability. So maybe when you have a very easy to dismantle product, it can have a negative impact on the durability. And so I think for every design challenge, there is a trade-off with many dimensions. So that's also interesting to take into account. And then if we see how Philips is using it, or what Francesco was telling us, so keep in mind that disassembly, it's only a mean and not the objective. And so you need a strategy first, and then look what disassembly can add to that strategy. And for that, it's very well, you need a value driver, and that's also what we always in CIRCO try to do. There is a combination between your business model and your design readiness, and they go hand in hand. So it's also probably an iterative process. So what are your value drivers? How can design add to that? And then what role will disassembly play into that? Then another thing, if you look at the strategy, they can be very different for different product groups. And that was also where Francesco was referring to, but also what came out of the groups. So if you are with a consumer product, it's maybe more on self-repair and on making spare parts available and things like that. While when you are in a professional market, maybe you can add service packages and you can integrate predictive and other types of maintenance. And so it really depends on the market where you're in, the relation that you already have with your customer, and also then the characteristics of your products. So they can lead to totally different strategies, and then also to different requirements with respect to your design and also your design for disassembly. But whatever you're going to do, bring it into your process at the start. And that's what Francesco learned us, but I think that's also what Tom showed us. And so I think very important from Tom, it's also just start doing things. And sometimes it may be very complex, but also in other occasions it can maybe be very simple, like with the chair that Tom showed us. And there was also an immediate option for someone, a company that is producing chairs, to add value drivers to his business models with a web shop or with other things. So then you can make concrete steps, maybe not totally prepare a chair for disassembly, but at least make some steps on certain components that already make a first step into this. So maybe this is some wrap up. I think I learned a lot, and I want to thank everybody for its contribution, and hand over the word to Petra.
Yes, yeah. Also, maybe we can give like a digital hand to the speakers, to Francesco, Bas, and Tom. Thanks a lot. And also thank you for your presence. And as said and also mentioned in the chat, we will share the information with you. So the links that the webinar that Francesco mentioned, some links from TU Delft. So we'll make sure that you get also the recording of this meeting will be sent to you. So thank you. And just in time, 5:30, we finish this expert session.